We're going to do the first free response for review day 5, and they give us a function g, tell us where it's at 1, and what its derivative and second derivative are. And the first question we're supposed to figure out is where all the values between 0.12 and 1, where g has a horizontal tangent. So the first thing we got to think about is, to have a horizontal tangent line means we'd have a slope of 0 on that, so that means our derivative would equal 0. So on your paper you want to write derivative g equals 0, and if you wrote that you'd get 1 point, just for telling the grader that you understand that's kind of what you have to do first. Then on your calculator we'd put in the first derivative, and then what we want to do is go ahead and hit graph, and we have the graph looking like this. And we can see that it equals 0 at here and here. So now we'll go to calculate 0, and we'll get this one first. So left bound, right bound, enter. First 0 I see there is 0.163. And then the other one, if I go left bound on that, and right bound on that, enter, is at 0.359. If you had those two answers, you get a second point. All right. Part B says, on what subinterval of this is the graph of g concave down? Now g will be concave down when either its first derivative is decreasing or its second derivative is negative. And since we were given both of them, it's up to you to decide which way you want to do it. Now to me, I think it's going to be easiest if we do the second derivative being negative. So I'm going to come in here, turn the first derivative off, turn the second derivative on, hit graph, and we can see that it's negative right away, and then looks like it might be, something might be going on over here, we're not really sure. Also looks like something might be happening there. It might be good for me to increase my window, get a little bigger picture on this. So I'm going to go -10 to 10, see if I can get a little better look at what's happening here. And can't really tell again over here if that's going to be negative. We'll check that out in a little bit. But first, for sure, we're negative here. Now it looks like we might be negative even there, right? So I'm going to hit trace, and let's see what's happening over on this side here. So bring our cursor on over. We'll find that point in a second. And sure enough, you can see the little markers right there. So there's a little spot right there. It's you again with the color screen probably see this a little faster than we do with the black and white. So what we're going to do is calculate the 0 there. All right. So left bound, right bound, enter. All right, it equals 0 at 0.129. So from 0.129 at the start, and then we'll calculate the 0 at the other spot there. So left bound, right bound, enter, 0.223 it looks like. All right, so we know that it's here because that's where g double prime is negative. All right. Now, it would be helpful for us just to make sure that nothing else is happening on the other side. So if I hit trace and I let this go, I just kind of want to make sure that it doesn't go into the negatives over on that other side. So as we get closer and closer to 1 there, you see we're getting closer and closer to 0, but doesn't equal negative anytime there. It equals 0 at the very end, so we're all good. That's the only time that the second derivative is negative. You would have gotten 1 point for that interval and 1 point for the reason why it's that way. All right. Now, C says write an equation for the tangent line of g at x equals 0.3. And this is a real sneaky. It seems like that would be an easy question, but there's some parts to this that aren't obvious. So we're going to do C down here. First thing, of course, we're going to try to find is a point and a slope. And they give us the x-coordinate of 0.3, and that's what makes this a little trickier, is because the y-coordinate of 0.3 was not given to us. What we were given was the y-coordinate at 1. So what we have to do is figure out what g equals at 0.3. In order to do that, we're going to say, all right, g of 0.3 is what it was at 1, which was 2, plus how it changed from that time to the time we want to go. So we have to actually set up an integral here of its derivative. So it's a concept we've done before, but it just wasn't obvious that that's what you'd have to do in this problem, right? So if you set this up and you work it out, what you're going to get is 1.546, okay? And that's your value right there. And then as far as the slope goes, that's g prime. So we're just going to put 0.3 into the g function. And if you do that, you get a negative 0.472. Negative 0.472. So our equation of our tangent line then, y minus 1.546 equals negative 0.472 times x minus 0.3 or 0.3. They gave 4 points on this. They gave 1 point if you had the right slope. So if you put it into the derivative correctly, you got a point for that. You got a point for understanding that you needed to set up an integral expression to get the g.3. You got another point if you had that value correct, and then you got a 4th point for having the right equation. Now, I think if you messed this part up, but you still made an equation out of your values, you probably still get this point. So that's the perseverance. Keep going, even if you're not 100% sure. Keep trying, go work the whole problem out. Do what you do know how to do, which is set up an equation of a tangent line. Don't let something else stop you, right? Now, D says, does this line tangent to the graph lie above or below? And that's going to be working on the second derivative. So what we want to do is put 0.3 in for the second derivative. And if you do that, what you end up finding out is that you get a positive value in the second derivative, that is. And so since we get a positive value, that means we're concave up. And our tangent lines then are going to fall below because of that. So our tangent line is below because the second derivative is positive for 0.3 x1. Okay, and that was just worth 1 point to say that it was below, and y gave you the point there. All right.